So moving on to the main part of the lesson. These are the sorts of questions that we want to be sort of asking ourselves and answering. Um, so the first one we've got is, what does equal groups mean? I'm sure that you'll already know that equal means that they've got to be the same. Sometimes when you're looking at looking at different groups, you need to think about what is the same and what's different about them. If they're the same, then that means they're equal. If they're different, why are they different? It might be that there are actually equal groups, but they look different. How could you make the groups equal? So you need to be looking at the groups and thinking, right, what can I do to make all of these groups equal? It might be the fact that you might have to add another one. You might have to move one from one group and put it into another. Think about which groups got the most, which one's got the least. Do the groups look the same? Does it matter? As long as they've got the same amount in, they are equal. Can you find different ways to represent these groups? So it might be that you draw dots. It might be that you do a bar model. It might be that you use jotting, so you use dots. You actually draw the pictures. When we are sharing them and we're counting up groups, or if we're sharing them, we don't always have to just do one. You can try and skip counting other numbers. So maybe you know your 2 times table, your 5 times table, your 10 times table, or your 3 times table. It might help you to count quicker and therefore work out the answer more quickly and efficiently. Final one, can you describe the groups and the number of groups? So when you are looking at some groups, you can describe them. So I have got 3 groups with 5 in, and the total is 15. So it's coming up with sentences that you can say and present. So for example, we have this here. We have got, I would say we've got 3 equal groups of 3. All of the groups are equal, they're all the same, they're all the same picture, they're all in a nice pattern, in a nice sort of in rows and columns, so they're just, everything about it is equal. So those are the sorts of sentences I can come up with. Looking at this one here, if you count how many children there are 5 children here and 5 children here, but what's the same then? So they've got the same value, so this group's 5 and this group's 5. One group, they're different because one sat down, one stood up. Some of the children are different. So there are lots of things that you can discuss about equal and unequal groups. And this one in particular tells you that as long as you've got the correct value, an equal value, it doesn't matter how they're presented. So it might be that your work's a bit messy, but as long as you can see that there are 5 or whatever number it is, 2 equal groups or 3 equal groups, then it doesn't matter too much as long as you know that it's equal. So they are both equal. So then we've got this question here. So it says, which groups are Leah and Chen describing? So Leah says there are 2 items in each group. Which set am I thinking of? So we read this question, we think, right, there are 2 items in each group. It's not asking for how many groups there are, it's asking for how many in each group, and that is the number 2. This has 5, this has 6, this has 10, this has 2. So Leah is thinking of this one. Chen says there are 3 groups. Which set am I thinking of? Now that's changed because we're looking at how many groups there are now. How many groups are there? 3. There are 1, 2, 3 there, 1, 2, 3 there, and 1, 2, 3 there. So sometimes questions might ask for 2 answers, or they might ask for another step. So it's just making sure that when you are reading these questions that you follow carefully and know exactly what that question is asking you to do. So the pencils is right for 1 and 2, and these donuts are 2, and the biscuits are correct for 2, or Chen. Okay. Here we have another question. This is one where we are looking at making equal groups. Sammy has tried to group these counters equally. What mistake has she made? Use counters to show how to make 3 equal groups. Now, what I would do if I was solving this, if I was doing this question, is I would look at this and think, right, that's 4, that's 5, that's 6. Which one has got the most? I would say that this one's got the most because it has a value of 6. This one's got the least, so I'm going to give one of those to the one with the least in, because if I move this one here, then that means I've got 5 here, 5 here, and 5 here. Okay, so one group is 4, one is 5, and one is 6. These are not equal, because if I take 1 from 6, this answers 5, and if I'm taking 1 from here and adding it here, 4 plus 1 is 5, so they all have the value of 5. The next question says, can Sammy make 2 equal groups using these counters? Now, this is a 2-step question because it's asking you to see if you can make 2 equal groups. Now, the first thing you need to do is you need to find out the total. Now, if I've got 5 plus 5 plus 5, I can skip count 5, 10, 15. If I've got 15, okay, this is when I can try and sort it into 2 equal groups. But thinking about the lesson that we've done this week, 15 ends in a 5, which is an odd number, and an odd number you cannot divide into 2 groups. It's odd. So you will have 1 left over. So the total number of the counters is 15. It's an odd number, so it cannot be divided by 2. You would have 7 in each group and then 1 left over. So please, can you have a go? These are still worded problems linked to division, but please have a think about those questions. If we go back, what does equal groups mean? What's the same? What's different? Making sure that all of your groups are equal. Okay, doesn't matter if they look the same, as long as they are equal, then you can find the answer accurately and efficiently.